Elasticsearch is first and foremost a search engine. It is designed to index content so that it can be retrieved quickly. Think of it like Google for an endpoint. Indexed information represents a portion of the original data, and as a result, what we are left with is actually metadata, or data about data. We can use the index to store key pieces of data that describe other data, or in the case of logging, we can put all of that data into the index. And whoever creates the index template dictates what fields will be indexed and how they will be treated. And Elasticsearch, which we'll use today, uses JSON to manage and store data in this system. That's JavaScript object notation. And the way that it's structured is that it uses a key equals value data object. And we're searching for those keys. So let's jump into it and open up your ELK application. I'll try to cover some of these terms as we go along, as there's a lot of terminology, but this is more of a lab, so let's get going with some of it. On the top left, click that little hamburger menu, and then select Discover. The Discover application provides us an interface to select an index of interest, and then using query languages, such as either the Kibana query language or Lucene syntax, we can devise our queries to return relevant data. And if we want to see the index we're currently on, if we just select the little drop-down menu underneath the Add Filter button, you can see we're currently in the Foundations index. Now we just need to adjust the time. By default, it's set to the last 15 minutes. Top right, we can select the Show Dates button, or select the minutes itself and make an adjustment. Let's change it to last 1 year. And if we do, you can see there are 22,000 hits. These results are provided with a histogram as well at the top, which provides us insight into the number of matching records. And if we want to zero in or zoom in on that, we can just use our mouse and drag within the view of the histogram from a time frame, and it will zoom right into it a little bit further. So I'll do that a couple more times, and as you can see, as I continue to zoom in, we get a much more insightful understanding of when these events occurred. Now let's go and open up one of these events. If we scroll through, you can see how they're all structured to that key value pair. Let's expand the top one that just appeared as the first entry. As you can see here, we have these fields and values. The fields are the keys that we're trying to search for, and the values is the information we want to obtain from the keys. Let's select the JSON column there now at the top, and this will give you a better understanding of how this data is formatted. As you can see, in blue, we have all of those keys, and those are the fields that get represented inside of the event, and then that's their respective value. It's a little similar to the registry key values that we saw as well too inside of Windows. As you can see, we have an incredible amount of detail here. So you can start to appreciate the breadth of what a security analyst has to go and sift through. There's just so much, and this is at least still better than going inside of Windows event logs and looking for logs individually as we did in the previous labs. Another benefit of using a software like ELK is that it actually provides some level of common occurrence. If you see me dragging my mouse now on a left-hand pane, and I select any of these fields, you can see that ELK has performed a level of analysis of what are the top 5 values. And that allows you to kind of drill down on the noise and identify something that's sticking out or something that's really occurring quite often, and for you to investigate further with it. Now, we as analysts, we like to build up our columns, so to speak, where we identify some of the more important types of values or fields that we're looking for. Something like process name would be really helpful for us to understand which of these events have what level of process.name information. So let's scroll down to process.name, and then we're going to select that little plus button right next to it, and notice how it adds another column here. This is much easier to navigate instead of going inside of each of those individual events and looking for the process.name. So we can continue to build out this column as we like. And now if we add process.command_line, you can see we have each event, the process name, and any command line interactivity with it. So that's kind of cool. So we can see that on July 10th at a given time, we have SVC host running certain types of commands with different types of flags and options. And this is how we drill down on information. And the columns are easy to work with. We can select those little arrows and kind of move them back and forth, left and right. And this helps us visually get a sense of what's going on. Okay, so let's say we've added some columns, but they're not really helping us out much. We can just go and hit that little X button and send them right back to the left-hand pane. Okay, so now let's actually move on to querying. We can use the KQL or Kibana query language to enhance our queries and to ensure that they're more effective at retrieving relevant data. Remember, Elasticsearch is a search engine. Just think of it like Google for your endpoint. And as such, it will deliver you something depending on whatever you put in as a query. And that's kind of a blessing and a curse sometimes. And I say that because sometimes it might deliver you something and send you down a rabbit hole. So with that being said, there are some levels of consideration to take in building your search. First is to maybe consider your temporal filters, such as the time. So what time will you search against? Secondly, what are you actually interested in? Do you want to use the available fields to return relevant results, or will you just search for random strings? Third is to verify that your Boolean operators are returning the correct data. And fourth, make sure that you're utilizing the hits to understand the number of results returned and the general performance of your query strategy. If your query is returning 100,000 plus results every single time, you might want to consider how you could drill down further on it. You want to be more specific, right? So let's do some searching now, and we'll search for a term of desktop. And as you can see with the results, there's still quite a lot. What we can do now is actually wrap our search inside of quotes. And while it won't really provide us with a lot of additional hits right now, just searching term for term, we'll want to use this type of search convention when we start matching it against fields or these keys. So let's do just that. Let's search against the agent.hostname field for this desktop over here that we're seeing of FD32URT. And let's see what it comes up with. Okay, so now we're down to 13,000-ish hits. That's much better. So you can see as we start to drill down, matching these fields against more specific search terms and patterns, it gets a little bit better for us to identify specifically what we're looking for. Now, we can also search by wildcard, kind of like how we've done on the command line. We can use the asterisk to specify anything that ends after a certain letter of characters. Let's search for DES with the asterisk and see what the results come out to be. So from here we can ascertain, just by using partial search patterns like this, how we want to further refine our search queries. And this also extends to the individual fields themselves. So the subfields, if we're not sure what they might be, we could also throw a wildcard inside there as well. So agent.star.des star will provide all the hits related to any type of subfield underneath agent, but then also the final term or value has to match DES, and then any other number or types of characters after that. Now let's throw in some more operators over here. There's the Boolean AND operator that we can work with. And let's search for registry and agent.hostname equals the desktop that we're working with in question. Okay, so this is interesting. We have 100 hits now from this desktop with registry events. Now we're getting somewhere, right? Now let's look at another operator of OR, and this will allow us to ensure that at least one term is matched and returned. So kind of an either or, hence the OR. Let's search for something maybe like user.name is equal to local admin, or user.name is equal to system. So that's kind of cool. We have about 8,500 hits over here that have elevated permissions. And that could help us identify further what's going on inside of these events. There's also a third way to use these operators using the not operator. So let's say we wanted to search for events that didn't have the username of system. Well, if we just said not user.name is equal to system, we'll get all the events related to anything that isn't the username of system. And we can also perform grouping of these operators too. So if we said we wanted to get events that weren't of username.system, we could put a bracket in the beginning, and then we could throw an OR inside there as well too. And let's use another username, but let's go and check out and see what other usernames have more common occurrences. So we see some of service. So let's say anything that doesn't end in service, and then we'll wrap that inside of brackets and search for this. So that's kind of cool. So now we have a whole bunch of events given to us that don't belong either to system or anything ending in a service account. So now we can kind of drill down even further, right, by doing things like this. Now we just have two other things we can look at here, and one of which is to use greater than or equal signs. So to define a quantity. We could search for destination traffic that is greater than or equal to 500 bytes in size. So let's perform a search for that. We see 93 hits returned to us. Now let's actually go in and add a column for the destination.bytes, and we can get a line-by-line entry of all the events with their given levels of byte transfer. So this is kind of cool. Now we can drill down even further and see some of these are pretty large. Maybe we want to inspect that. There was a file transfer going on. So kind of cool. And then lastly, one really handy sequence of filters and columns to line up would be to search for process.command_line is equal to anything. So we have some level of command line activity. And then we can go and add a column over here, and we can go in and add process.command_line. And then we can get a huge list of all of the command line activity based on all the events. That's really handy if we're looking for something malicious running on the command line. So as you can see, once we start using a more powerful tool like ELK, and all the other types of log analytics software are very similar, you can get this really deep view of what's going on inside of the network. If all of your endpoints are sending logs to this index, and then we're using the metadata related results of those logs, we can really specify our queries and get right in there and find out which user is doing what process is talking to which, what command line arguments are being fed to where, and what level of network transfer is even happening as well. Very powerful stuff. And it's tools like this that really make cybersecurity analysts be able to do the job they're able to do day to day and inspect and identify where malicious activity is occurring.